Close your eyes for a moment. Imagine absolute nothingness. No stars shimmering in the night sky, no galaxies swirling in the darkness, no planets turning silently in their orbits, not even the faint ticking of time, just an endless, incomprehensible void. But here's the haunting paradox. If the Big Bang, 13.8 billion years ago, was the moment when everything began, then what was there before? The question itself bends the mind, because before means time. And if time itself was born in the Big Bang, then can before even exist? Or are we trying to use human words to describe something far stranger than we can imagine? This riddle has troubled the greatest thinkers, from Einstein to Stephen Hawking, from ancient philosophers to modern cosmologists. Every time we try to push past that wall, we enter a realm where science, philosophy, and even spirituality start to blur. Was it an infinite ocean of universes bubbling endlessly into existence? Was it a cosmic rebirth, where each Big Bang is just one heartbeat in an eternal cycle? Or was it something far more unsettling? A true nothingness, so alien to human thought that our language itself collapses when we try to describe it? Tonight, we are going to journey into that darkness. We will peel back the layers of one of the greatest mysteries in existence, to ask, with courage and curiosity, what if anything existed before the Big Bang? The story begins 13.8 billion years ago. There was no sound, no space, no passage of time, just a singularity, a point smaller than an atom, denser than anything our minds can grasp. Inside it, the totality of the universe lay hidden. Every star that would one day ignite, every planet that would one day form, every living being that would one day breathe. All of it compressed into a cosmic seed. And then, in a fraction of a second, it happened. With a flash of unimaginable energy, the universe erupted. Not like an explosion in empty space, because space itself did not yet exist. Instead, space was born in that instant, stretching outward in all directions, faster than the speed of light. The numbers are staggering. In less than a trillionth of a second, the universe expanded from something smaller than a proton to something the size of a grapefruit. And it kept expanding, cooling, shaping itself into the vast cosmos we know today. The heat of that moment is beyond comprehension. Imagine the core of the sun. Now multiply that heat by 1 trillion. In those first instants, matter could not exist in any stable form. Particles blinked in and out of existence in a violent storm of creation. Energy surged, space stretched, and the laws of physics as we know them today began to take shape. This was the Big Bang. But don't let the name fool you. It wasn't a bang like a firecracker or a bomb. It wasn't noise at all. It was the birth of reality itself. And here's the detail most people miss. The Big Bang wasn't just the origin of matter and energy. It was the origin of time. Think about that carefully. Every second you've ever lived, your first breath, your first memory, every joy and every heartbreak, all of it exists on a cosmic timeline. And that timeline began 13.8 billion years ago at the very instant of the Big Bang. Before that, there was no yesterday, there was no ticking clock, there was no before. This is where the human mind begins to struggle, because our brains are wired for cause and effect. If a tree falls, there must have been wind. If lightning strikes, there must have been a storm. If the universe began, then surely something must have caused it. And this is where we hit the wall. Because if time itself started with the Big Bang, then asking what came before is like asking what lies north of the North Pole. The question seems to break under its own weight, yet we can't help but ask. Our curiosity demands an answer. We are not satisfied with nothing, because can there ever truly be nothing? Or is nothing itself just another kind of something, waiting to be understood? It is here at this razor's edge between knowledge and mystery that science, philosophy, and spirituality all collide. Scientists propose bold theories, from the bubbling sea of quantum fluctuations to universes cycling endlessly through birth and death to infinite multiverses beyond our reach. Philosophers wrestle with whether nothing can even exist at all, and ancient traditions whisper of eternal cycles, rebirths, and cosmic rhythms. The closer we come to the beginning, the more mysterious it becomes. And so we ask the haunting question again, what if anything existed before the Big Bang? Chapter 1. The Quantum Foam and the Vacuum Fluctuation. When we think of nothing, we usually imagine empty space, a silent void, a blank canvas with no particles, no energy, nothing at all. But here's the strange truth revealed by quantum physics. Even the most perfect vacuum, a place stripped of all matter, all light, all radiation, is not truly empty. At the smallest scales of reality, the quantum level, nothingness boils with activity. Tiny particles, electrons, photons, quarks, are constantly popping into existence and vanishing again in the blink of an eye. They're called virtual particles. This restless dance is known as quantum fluctuation. Imagine staring into what looks like an empty black void, and then realizing that, beneath the surface, it's alive with flickers of energy, tiny sparks appearing and disappearing so fast we can barely comprehend it. Now here's where the mystery deepens. Some physicists suggest that our universe itself may have been born from such a fluctuation. Think of it like this. You're watching a pot of water boil. The surface looks smooth at first, but then suddenly a bubble appears. That bubble grows, expands, and rises up from the depths. That's the analogy. The boiling water is the restless quantum vacuum. The bubble is our universe. In other words, the Big Bang might not have been a singular miracle from absolute nothing, but rather a rare and powerful fluctuation within a deeper quantum sea of possibilities. This isn't just poetic speculation, it's rooted in the mathematics of quantum field theory, which describes the universe as a vast field where energy can never be truly zero. Even when stripped bare, there's always a faint hum, a quantum foam, bubbling with potential. In this framework, the phrase "before the Big Bang" doesn't point to nothingness. Instead, it points to a hidden, frothing ocean of energy, invisible to us but seething with creative potential. From that sea, one fluctuation, perhaps unlike any other, inflated into something far greater, our universe. And here's the mind-bending part. If this is true, then the universe may not be unique. Other bubbles might also be rising from that same quantum sea. Some may collapse instantly. Others may grow into entire universes with their own laws of physics, their own timelines, perhaps even their own forms of life. To us, our universe feels vast and singular, but from the perspective of quantum foam, it could be just one bubble in an infinite boiling pot. So, when we ask, what existed before the Big Bang? The quantum view suggests the answer is not nothing, but a restless, eternal energy field, a fabric of reality that is never still, always seething with the potential to create worlds. From that sea, one fluctuation, perhaps unlike any other, inflated into something far greater, our universe. And here's the mind-bending part. If this is true, then the universe may not be unique. Other bubbles might also be rising from that same quantum sea. To us, our universe feels vast and singular, but from the perspective of quantum foam, it could be just one bubble in an infinite boiling pot. Chapter 2. The Cyclic Universe. But what if the Big Bang wasn't the first, or the last? Across history, human civilizations have struggled with the idea of beginnings. For many, the thought of something appearing out of nothing was too strange to accept. And so they imagined a universe that never truly begins or ends, a universe that cycles eternally. Take ancient Indian cosmology. Thousands of years ago, Hindu philosophy described the universe not as a straight line, but as an endless cycle of creation, preservation, and destruction. The cosmic dance of Brahma, Vishnu, and Shiva, gods symbolizing birth, life, and death, mirrors the idea of a cosmos that is constantly reborn. According to these traditions, billions of years pass in each cycle, a time frame eerily similar to the ages modern science talks about today. Now, fast forward to modern physics. Surprisingly, science has echoed this ancient intuition with what we call the cyclic universe theory. Here's the idea. Our universe is currently expanding. Galaxies are rushing away from each other, carried outward by the mysterious force of dark energy. But what if this expansion doesn't go on forever? What if, billions or trillions of years from now, the push of expansion weakens and gravity takes over? If that happens, the universe will begin to contract. Galaxies will draw closer. Stars will collapse into one another. Matter itself will squeeze tighter and tighter until eventually, everything crashes back into a single, incredibly dense point. A big crunch. But that would not be the end. Out of this final collapse, an immense explosion could erupt again. Another Big Bang. Birth, death, rebirth. In this vision, our universe is not a one-time miracle, but a single heartbeat in a cosmic rhythm that has been pulsing forever. One universe collapses, another is born over and over through infinite cycles. Imagine it for a moment. The night sky above you, the stars, the galaxies, the great cosmic web, is not the ultimate reality. It is only the latest version, the newest chapter in a book that has been written and erased countless times. Maybe in some previous universe, life flourished on planets beyond our imagination. Maybe entire civilizations rose and fell long before our universe even existed. And when this universe eventually dies, new ones may rise again, with their own stars, their own galaxies, perhaps even their own beings wondering about their origins. Some physicists even suggest that traces of these past universes might be hidden in our own cosmic microwave background radiation, the faint afterglow of the Big Bang. Tiny imprints, like fingerprints from an earlier cycle, etched into the fabric of the sky. It's a breathtaking idea, that existence itself has no beginning and no end. That the Big Bang we speak of so reverently is not the beginning of everything, but merely one chapter in an infinite, repeating story. And if this is true, then when we look at the stars, we are not looking at a one-time miracle. We are looking at just one verse in the eternal poem of creation. Chapter 3. The Multiverse Hypothesis. Now take a leap into one of the boldest and most mind-bending ideas ever proposed, the multiverse. To understand it, we need to go back to the very first moments of the Big Bang. Scientists believe that right after the universe was born, it underwent a period of cosmic inflation, a burst of expansion so rapid that in less than a fraction of a second, the universe grew from smaller than a proton to larger than an entire galaxy. This inflationary period stretched space itself faster than the speed of light, not breaking physics but reshaping it. Matter, energy, and even the structure of space-time were pulled outward in a cosmic surge. But here's the twist. Some scientists believe inflation never fully stopped. While our patch of the universe stabilized into stars, galaxies, and planets, inflation may have continued elsewhere, endlessly. Like boiling water on a stove, new bubbles of space could be forming all the time, each one expanding into its own universe. If that's true, then our universe, everything we can see through our telescopes, all 2 trillion galaxies, is just one bubble in a far larger cosmic ocean. An ocean filled with countless other universes. And these universes may not look anything like ours. Some might be eerily similar, with galaxies, stars, and planets almost like ours. Maybe even other versions of you, living slightly different lives. In another universe, maybe you made a different choice, took a different path, and are now living an entirely different reality. Other universes, though, could be unimaginably alien, worlds with different laws of physics. A universe where gravity is weaker, so stars never form. A universe where atoms can't exist, leaving nothing but endless radiation. Or perhaps universes far richer than ours, where life thrives in forms we could never even imagine. This is the haunting possibility of the multiverse. Our Big Bang wasn't the beginning, it was only a beginning. And what came before our Big Bang might not have been nothingness at all, but simply the aftershock of another universe, bubbling into existence next to ours. Some scientists even speculate that collisions between universes could leave scars, faint imprints, in the cosmic microwave background, the radiation still echoing from our Big Bang. Imagine looking up at the night sky and realizing that a strange pattern of light is not from a galaxy, but from the brush of another universe against ours. The multiverse is controversial. Many physicists argue it cannot be tested, that it drifts into the territory of philosophy rather than science. Yet it remains one of the most compelling answers to our greatest question. What came before the Big Bang? Because if the multiverse is real, then our universe is not the story. It is just one story, among countless others, written in the infinite library of existence. And we may never know if ours is the only tale, or just a single bubble among endless others rising from the dark cosmic sea. Chapter 4. The No Boundary Proposal. In the 1980s, Stephen Hawking, alongside physicist James Hartle, proposed an idea so radical that it still unsettles scientists today. They asked, what if the question itself, what came before the Big Bang, is flawed? Here's why. We usually think of time as a straight line, a timeline with a clear beginning, stretching forward into the future. On such a line, it makes sense to ask, what came before? But Hawking suggested that at the deepest level of reality, time is not a straight line at all. Instead, time might be curved. To visualize this, think of the Earth. If you look at a globe and walk north, you eventually reach the North Pole. But once you're there, the question, What's north of the North Pole? Doesn't make sense. There is no north beyond the pole, not because something is hiding there, but because the concept of north simply stops existing. In the same way, Hawking argued that the Big Bang was not a beginning in the sense we usually imagine. It was not the edge of time, not a singular start point from which time flows. Instead, the Big Bang was like the North Pole, a place where the concept of before loses meaning. This is what Hawking and Hartle called the no-boundary proposal. In this model, the universe is finite, but it has no boundary. Like the surface of the Earth, it is closed and self-contained. You can travel across it forever, but you'll never fall off an edge. So what does that mean for time? It means that the universe didn't need a before to begin. Time simply curved smoothly into existence with no sharp starting point. There was no singularity, no infinite density, no something from nothing. Instead, the birth of the universe was a natural, seamless transition, like the Earth curving gently from one hemisphere into another. Hawking put it simply, asking what came before the Big Bang is like asking what's north of the North Pole. The question itself collapses because it doesn't apply. For many, this is deeply unsettling. We want clear answers, neat causes and effects. But Hawking's vision is stranger and perhaps more elegant. The universe may not have needed a cause at all. It simply exists, finite but without boundaries, without a before. And in that picture, the Big Bang wasn't the beginning of everything. It was just the point where time and space curved into the form we now perceive as reality. It's a theory that doesn't just challenge science, but human intuition itself. Because our minds crave origins, we struggle to accept a universe without one. Yet perhaps that is the ultimate mystery, that existence may not have a beginning. It may simply be.